Good morning, or whatever it is, wherever you are. I have to remember exactly where we left off. We were getting towards some of the abstractions necessary to sort of make a wrapper program. Just to kind of get all of this stuff sort of as things you wouldn't have to think about most of the time. And then I have to kind of go back to the main program part and say, okay, what else can we get out of our face? I've abstracted that stuff a little bit. We've got our effect stuff, and so right now, our main program is going to have to be returning effects in the same way that we would return commands in standard Elm. We need to, one step in this is going to be separating models and updates. Have we already separated the updates? HTTP managed, remember HTTP request deals with that. No, actually, it's not pending request, it's next request ID. Okay, so those are already sort of pulled out of the main update. It does not deal directly with them. Or we're dealing with functions rather than an update, per se. So having some levels of model would sort of get us one step closer to being able to completely separate that. And is this? Yes, this is down here. We pulled it off to this section. So we've got our main model. And better names for this probably. And we've got that model. Now this, wow. It's not parameterized yet, although we can expect that probably when we parameterize message. Now you were model. So you don't care, well, you're going to care about parts of your type. Oh, you know what? There's a different version of this. Is there? Well, there's a couple levels to it. We can not quite go full out on this by making this Yep. Oh, are you still going to be parameterized? this might still be parameterized on the base type. Okay, so let's just, we got, these ended up duplicated. Okay, so that's compilable. And then the place where we use this, all you care about is that it's of that type. Hello, Imamzi. How's it going? Did my information? No. This says everything got categorized correctly. Is it not showing up for you? Does something look inappropriate for how I've put things up on Twitch? Okay, so that one passes. I am doing something the hard way as a learning exercise. I am making a Lambda, AWS Lambda function to handle the authentication changes that we recently made to the Twitch API, which runs a web application and a Twitch extension that does sort of dynamic calendars for Twitch schedules based on previous video times. The hard part is that I am using Elm, which is like a compile to JavaScript language with immutable data and generally a functional programming style that is really primarily targeted at front-end browsers, and it is not at all adapted to the sort of more node-like environment Lambda is in. So I am having to kind of recreate a bunch of stuff from the standard library from scratch. Hey, what you dev? How's it going? So I'm kind of slowly evolving my earlier versions of that towards something that could maybe be sort of a semi-reusable framework for doing Lambda stuff in Elm. I mean, that may still be unwise. It's certainly a heck of a lot more code and effort than in just the plain JavaScript was. This is Elm. It's a... I don't know what the best list is. It's a functional, immutable, statically typed, compiles to JavaScript. I understand that many people do use it with Elixir on the back end. I'm one of those people who wants to go do some Erlang first, so I have a better understanding of the groundwork before I do Elixir itself. But I just haven't quite made time to do that yet. So there's you. HTTP match also did this. Okay, that's still typable. So we've got what this thing requires in terms of its model is just, and that works because there's still type system support for extendable records, even though you can't actually dynamically update things. So all that's saying is that anything with these two fields works. And what we want to do is actually make a more concrete version of this. Oop. Which Does the type system say anything about the fact that it's an HTTP model? If I put it in here, what we would say is that the thing this is based on has to be that, which is not what we want, what we've got. We want to get to this being an HTTP model and also having a app field, which this will be our model type. We could certainly start here. Yes, a couple of the things or projects are linked below, including earlier versions of this. Let's see, that doesn't go to me. I don't know that any of, well, a little bit of this is pushed up because I did publish a much earlier version of it to get the web one going. I always mistype that. Which is that's what we're moving towards. So the Lambda request is doing the Twitch requests to get the video data. Thank you. The extension version of this is still using the direct requests from the front end only. Yeah, I actually don't pay attention to profiles much. I guess I just kind of try to do the code. Yeah, I didn't even know about this stuff. Are there specific things they do there, or is there like a sort of like widget plugin setup? All right, so the rest of the app is hopefully not dealing with any of these fields. If we say that's that, this is going to, I haven't done this a lot before, so it's going to be a little bit interesting to actually pivot everything. If we take those out, some of this stuff is going to have to change, and we're going to have to kind of rework it to make it a Lambda model, and then we're going to have to make it. Let's see. Do we want to put the wrappers around it, or do we just translate this to Lambda model and then do that? Well, all of this stuff wants to be in its own model, so maybe I need the wrappers first. So we're gonna need an init wrapper, an update wrapper, and subscriptions. This is down here currently. So that would actually be no like subscriptions from the inner application level. Maybe this program doesn't even, well, maybe you want to hook up with the ports. But right now we're only doing that, so there sort of wouldn't be that. So right now our init value is being put into initial model. Which is taking the end, which is something that is for like the inner section. Oop, did I save something weird here? Oh, you're right. It's not a variable if you're specifying it. I guess I should actually make that a variable so they don't have to go change that later. So I don't think it's actually in terms of that yet. Let's see, you would perform. Yeah, you're dealing with things that have those fields. And doesn't necessarily care about the submodel type, I think. Now this, if I start swapping these out, that's not actually going to work because maybe some things were referring to that and some things won't. Let's see, I don't think you're going to be directly referring to MEMs, to the subtype. Okay. So what do we have here? Oh, maybe things that are calling this. Yeah, update event perform. And that's Lambda update. Well, let's just tilt that on this section. Oh, actually, is perform an HTTP model, because that's all the functions it's calling depend on. But that hasn't really stated anything yet. All right, a Lambda event is calling the other update, so we'll eventually need some place to actually get that in there. And that update is a case where we do actually want to mention the inner model. So update would be of model.app. Actually, no. This one is going to have to specify this type, I think, because the update function is of a specific type, and then maybe it can come back and generalize this later, so that in a way that it's parameterized on a type. And HTTP match and that stuff. You're just going to care about that our model has those fields. And then we're probably going to start getting to the relationships between the types. Produces model effect. So we have to have some way to map the result of an update function back to Lambda model. So you are going to be an app and an effect. And perhaps there would be a nice little function we could do for this. And what we want to return is our model, where app equals app, and we have the effect. Okay, update, decode response. Second argument to update. And do you end up calling something that deals directly with the ability to record things? Okay, HTTP match is using a model that includes its fields. Oh, and then we're calling update again. So we got app, effect, oh, and you're going to have a model somewhere, aren't you? Model 2, which actually, this is not strictly dependent on that, because HTTP match is not going to be affecting the inner app. So this has to be M2 updated with that new app. Okay, and an update event. Because right, that's Lambda update. So this is where it forces us to these top level types. So there's Lambda update. Let's see, init. We're going to connect our own little Lambda init. And it's going to give us a Lambda model. This is going to be a concrete type for now. Actually, would you be... You would be more like... Bye! Huh. So this init would turn more into like an effect. Because that's going to be the level it's operating at. Which we might be able to kind of ignore that for now. Except I still have to pull it out. But properly speaking, I would have to get that effect and process it. All right, for the moment, we're back to let app effect you're going to give us a Lambda model. A Lambda model of model given whatever type. Actually, I guess I'm calling this app to try and distinguish it from the models from being too confusing. You're not decoding flags. You're passing flags through to here. And then I'm actually updating my program statement here. All right, we're still at update event. Lambda.event. Oh, you're just passing model through. So, Lambda update. Lambda model. You don't actually care about your type. Not directly, anyway. Maybe there's something indirect. Like update event is a specific type of model. Does it need to be a specific type of model? Right now, the update function we're calling is a specific kind of model, so that maybe. Update event. Okay, yes, complaint is not specific enough. We know from what it calls that it has to be this kind of model right now. Argument to worker. Lambda model of model. Oh, my subscriptions type is off. Okay, we are compilable. We are operable. So, to make this fully generic, our Lambda model has to store more functions. Well, do they have to store functions, or can that be closures? If the functions took arguments, and we closured in the next level function, so what we're concerned with is places here that call our bare update. So you would be an update function in submodel terms. Which would be message model Oop. And then instead of, well, it's going to apply to several levels of this, but to get one of these done, okay, so it accepts that. Now this function may be able to be generalized. Well, there may end up being some constraints here. The first branch is of type Lambda model model. Oh, okay, we missed an annotation. New event is a message. So this is another thing we're going to have to work out, how we figure out these message types. But this is definitely something we generate down. So that's one. Ah! Next 3 arguments got... Oh. Okay, we got that. And then Lambda update at this level is just here. And we missed one again. I missed a couple. Starting to wonder if I should have a type for app update function. Lambda init. We're also specifying a model here. Is there a way? Well, what we ultimately want to be saying is, I'm not quite sure how to put this, is that we have some sort of Lambda program. And is this a type in Elmland? Is that platform? Yeah, platform.worker. Okay, so there is a type of program. So a Lambda program is going to be a program, I guess, of value of a Lambda model of a variable type. And I don't think I've quite gotten messages to be variable yet. We want it to be variable, I don't know if we actually can. So that type is actually going to be, what it's going to return is that there's going to be a type for a Lambda program that's going to be possibly a little different. Or is it even a type? It's going to be an argument to it. Oh no, that's the return type. Following this, we have an init, which is our little subinit, which in this case, I don't know if we should, we ultimately don't want to constrain this. Although the init function I'm currently calling constrains it. Your update, we'd like that to be variable. I'm not sure we can. And we're not going to deal with subscriptions just yet. Oh, I can't just call these init and update because those are my top level names. I guess probably, well, modulars would be a way to disambiguate some of this stuff too. Would have been trying to keep everything together until I can get it better separated. So this is work error. Okay. Lambda program. All right, so Lambda init, which I kind of didn't really complete. So URL value. Well, if we're passing this in, we may be able to do flags. Except this would be flags. We're not calling this yet. We're still going to be type checking it. And then this collided. But now we have this name available. Which we also have to use down here. And maybe that update would be kind of appropriate, because maybe this thing eventually wants to be update. Lambda init. Oh, I'm still calling you here. I haven't fully instituted that yet. Lambda init definition. Type annotation says it's, this is where we might be able to take this step. Update is still constrained to be capital message, which means this is going to be capital message. Oh no, you actually are a Lambda message. Okay. And that's true, we are currently sending explicit types. So this cannot be abstracted from this program until we define where message is. Or rather, anything this stuff mentions has to be in the module where it's at or it has to be a variable. So like effect is here, currently message is not. So this is kind of an event from Lambda, this is an event from Lambda, this is an event from Lambda. No, these are HTTP responses. So we've sort of got that hook. But we need something like a subscriptions to say, here is the message I want you to send me in this condition, which at some level is going to be mapping some sort of Lambda event. Well, we've got Lambda events. We've got new event. That's the Lambda new event. We've got decrypted. And then got token is an HTTP response. So without doing a full subscription system, one thing we could do, well, I've actually tried implementing this yet. Can we say, and I'm realizing now I've gone way too long without a commit. Yeah, there's no type of annotation on there. Okay, that's compilable. It's runnable. I don't know if that transformation's complete, but we've done a lot of stuff. And I'm starting to get nervous about if I had to back out of something, I'd have to do it piecewise instead of just saying git reset. Oh, you know what I haven't done? Aha. Oh, that's the initial model. No, this is the initial model, not the actual type. I did all the stuff to move this out and didn't actually remove it from here. Okay, it's compilable. Which means we can't possibly be storing this stuff in the wrong spot. Oops. There goes that rubber band. And that might eventually be, some of these Lambda things might eventually become Lambda dot as they move into the module. And there are still some places we need to generalize our type annotations before we can pull that out. So, one way we can remove explicit references to these is to just kind of stick them in our program type for now, and then we can decide if we want to do a more general subscriptions mechanism. So this would be like new event. Decrypted result. Which is going to be exactly these. New event. Oh, you are, well, for the time being, that the type is message. Oh wait, you are a function signature now. And you are just a singular result to message. All right, so now you are there, and both of these are going to be needed in update. Yeah, so this is easy to get into the surface interface. It's a little bit annoying here. So you've got your update function, and then we've got other configuration. And then this is going to be some awkward types. which, especially annoyingly, have to get moved through here. Okay, so you're doing the command translation. If your update event, which we're only calling from one place, it's just the type signatures are becoming really awkward to have this one extra little step done for us. So it almost starts to become easier to just do the perform after all of these. And then this goes back to command Lambda message. I guess it was sort of nice to think in terms of effects there. But the way we're passing signatures around is really awkward, which is something, or should I leave that there and just deal with it for the time being? But every single one of these branches is going to have to do that perform. Well, you would become a command none. That's easy. And then the rest of these effects, which we have just gotten from our underlying system, have to get executed. Maybe this is even where we rewrite perform to take care of this little awkward step I haven't gotten to yet. All right, so I guess we don't deal with it yet. In the meantime, we need to rewrite this, though, because it's getting pretty obnoxious. And this might also make it easier to copy some stuff. Okay, so we do have some types changing here. Wait. If you're the same event, is Lambda message just a... It is just an alias, so I should probably be more consistent about that. Admittedly, you're directly switching off of it. All right. So... Or, Actually, can we uplift this to here? We lose a set of type signatures. But that's in it. But those type signatures are becoming a little bit awkward. And then this is indeed the place where we have all of that stuff. So update event. Well, we need these two things. As configurations. Wait, is that how I did it? Yeah, new event decrypted. And this expands very, very poorly if we start adding new messages, so I think that needs to be, definitely think that needs to be revisited. These are the kind of things I kind of like doing these exercises, because it kind of shows you why you have things like subscriptions and how they might work. It's trying to match system error, values of type lambda.event. The expression between case and of is a result. I seem to have gotten my argument order off here. So that looks like a new event. That looks like decrypted. Then we have update. I think this is fine precedence-wise. Okay, seems to be no change. Oh, your type signature does have to become, what was it, command lambda message? No, you're still a fact. And then the perform is giving us the signature that program needs. Okay, update event model. Oh, you know what? We may have been applying the event and model here. So that's kind of the one thing that we, well, so maybe this is kind of what gets passed around to something else, but we've got all those types built in. Well, this doesn't end up being very much. You still have to get the update function, which is this, which then we have to pass that signature to it. Yeah. Update event, because this thing, because we're getting the closured arguments here. Okay, it's event model, right? Event model. Is result string. Do I have insufficient parentheses? In fact, you're going to get insufficient parentheses too. So to have that as a separate definition, I would have to be able to write out this as the argument to it. Does the other function combiner here work with more than one argument? Oops. It seems it does not. Well, I'm not entirely sure what a subscription should look like here. Basically declare we have a binding for this, so you'd have to see if we have a binding for that. And it would just kind of become a no-op if it wasn't there. Okay, we still run. Have we purged all explicit message references? Well, some of the functions we're calling might still have them. So you kind of have to work bottom down or bottom up. Update event has it. HTTP match. Kind of missed that one. Oh. Where is that constraint coming from? Well, maybe... Maybe it's from some of these. Oh, HTTP model. So... Yeah. That's a type variable. So they do model message. Which means you have to be variable because you're holding on to this thing. And then every single one of these references has to be updated to some extent. Yeah, M. Wonderful. Yeah, so maybe the HTTP model wasn't the greatest abstraction. It kind of let us refer to some stuff while moving things around. Needs two, yeah, and then also affects our Lambda model because I guess I didn't have to do Lambda model right away. We could leave this as probably compatible. Except that places a constraint on something. Insert needs it to be probably HTTP request, which I think is still above the line. So you would have to be variable. Which means effect has to be variable. Shoot. So I think that's going to end up affecting my effects. Because this is a HTTP request. And as soon as we do that, it's turtles all the way down. Is that what core specs look like? Maybe that's if not, that's where they can do some system stuff. It's an expect message. I know that's affecting effects, which effects are similar to commands. So that kind of makes sense. Yeah, expect was already done. But this make a request is an effect. We deal with HTTP requests as an effect. And then it has to update a structure that has to store things that can ultimately send a certain kind of message. Even though the Lambda HTTP requests aren't going to be typed like that. So there may still be a sense in having those be separate. But the point where we turn these into effects, well, we might be able to cheat that there for a little while. That may still push that type constraint up. Yeah, so that's creating my HTTP model, where we go to HTTP request, where we perform. The model is a value HTTP model. Right, this is some model that has all the fields required by an HTTP model. But remember HTTP request needs it to be a message. May actually be one of the previous arguments. So we added a type to HTTP request. And we got an error on model, which is HTTP model. Model variable is variable. Remember HTTP request. The second argument to be an HTTP model of message. So that is the model from perform. Now you see update event is still in specific messages, which does it need to do that anymore? Because we passed in these in terms of a type. Now that probably is going to have to show up here somewhere. Oh, and then you take a message. So is update event now fine? I'm never completely sure if these are all part of the same run or not. So there's compiling. So these are all different messages. The argument to worker. Lambda model. Command lambda message. Update is HTTP model at model message. Okay, so the HTTP, we're getting a constraint HTTP model from somewhere. Oop. App update, we expect that to be fine. HTTP response, that's still, okay, so it might be this. Oh, and Lambda program. We're trying to work this out, but I don't know if we actually can. This is a pretty high level thing. And this we sort of expect to be getting relatively explicit arguments. And it's hard to say exactly where our difficulty is here. And there are obviously places that we need some generalization long term to actually do potentially variable things. I was kind of hoping we could put it off a little bit longer. So we took HTTP model to variable type. It might be this. But that means you have to have a variable now. Okay, and this specific instance would still be message. Your variable. You don't even care. This is currently variable. HTTP model. Remember HTTP request. Needs the second argument to be the model value is a variable. Now the model value where we call this HTTP model. Remember HTTP request needs it. Which suggests that this has constrained it. HTTP request. because that's the left to right. It's not... so a particular instance of this. Oh, is this effect still specific? Use it too many places. Yeah. So we produced an effect with message, which means an HTTP request message. It's an we're processing an HTTP and we're trying to remember it. So for this to work, we have to push our generalization all the way out through the effects in one big go. Now, maybe I could have done this in the other order. Although I guess there would be nothing to actually... Well, you could have applied the type variable to effect, even if it didn't need to be there. But if we do this, we have to do this. So the app stuff can specify that, similar to how command would. And all of this stuff will be just as constrained as it was before. Similar to how you would do command message all over the place. Actually, some of these functions are going to be general, like command fold was meant to be pretty general with all requests. That's a bit more specific. HTTP request. So that HTTP request, well, if that's variable, that would be variable. The net result of any of those calls would be a specific. Like these, we've named a particular message here, so it's going to be a particular message on the output. And we've wrapped. Oh, that's a list of effects. So there is a second reference to it. We missed one. It was right here, I guess. Missed another one. So you're still talking about specific messages. I thought I searched for these. Yeah, there's one. Lambda init is talking about general messages. You're talking about general messages. You're talking about general messages. Oh, maybe I got down here, the definition isn't actually at the top, so everything down below here. You're talking about specific messages. And that's back to top. All right, so we've done something to platform worker that it doesn't like. All right, value, lambda model, capital message. So we're still doing something that constrains the message type of lambda model. So our update function has gotten the wrong type. So message, lambda message. We're also, it looks like it's not recognizing update HTTP model and update lambda model are a little bit divergent. Well, HTTP model with a specific app model, and lambda model is a specific instance of that. So both of those are specific message types, so I think that should unify. The main difference is the message type that update is receiving. So maybe I put the wrong type somewhere? So this is platform worker. This is the actual Elm type, and we're trying to do lambda message. The argument is A. Worker needs the argument to be. So we have done, effect met, ew. So we need two types here is what this is. So I have to be careful about some of my effect message annotations here. Message, basically anywhere there's a command. You have to make sure not to use the same type. Unless we end up mapping things. Okay, so that got that stuff in terms of lambda message. We still have lambda model in terms of message, but that's kind of constant throughout, so that's sort of okay. Command sub updates in terms of lambda message. Argument is a record. Work error needs it to be. Command sub update. So let's inferred HTTP model for that with an app of that type. Oh, our is command. So we still got a command wrong type here. That's probably HTTP request. It's like we made these don't care, but some of these sort of do care. And probably the commands that Lambda will be receiving are of a constant type in a similar way that maybe I overgeneralized there. And those commands actually should be of a known type. Whatever Lambda does. Remember HTTP request. So that got confused. Body is a tuple of type. Request ID, expect app message. Type annotation says it should be a command. Okay, so we had some crosstalk with our message types there. No, it's possible. Let's see, our Lambda messages here. I don't know if these functions truly are variable. It's interesting that it's accepting the variable when we do things like Lambda HTTP request. Right, because they're not actually linked. We send something and something comes back on its own. There's no actual responses in any of our Lambda stuff. In practice, the command message here probably could be command Lambda message. So many more things have messages in them. Which is probably enough. I should commit that. Okay, so we've got those variabilized, which means we don't have to have a fixed message type necessarily. So it might be that there's a small step we could take now. So down here, well, so Lambda program is currently, this might have been the small step. And this is of a specific Lambda message type. Okay, and probably, well, no, you were there. Okay, so new event is a flags update event. Okay, so that one I should not have done. Those were not the same thing. So that did turn out to be a pretty small step. All right, so from this line, there are no references to message. There are probably some other things. Like HTTP request, I think, is above the line. Did expect end up somewhere else? Expect ended up down here. So there's two different levels of HTTP request. There is what we send over the port, and there is the thing that contains this expectation that we have to keep around. And that is kind of solidly moved into the Lambda layer. So Lambda layer is going to have two different HTTP requests. Did I ever abstract that? And I've been kind of wondering if HTTP shouldn't be its own module. The only thing is that then it ends up with its own ports to be truly independent. And if it has its own ports, then I have to have Lambda event types again, or tagged types. It's not just a singular thing coming back. Yeah, so we've got the type that we send over a port internally, which actually probably, well, we probably did publish that because that's what you have to send. Now, at one time I had sort of just inlined this here. And it looks like I could do that again. Maybe I thought I was taking a step there, and then when I added the expect field, it diverged. How about we just make this its own little type? I don't know that the outside would really need that. It's kind of handy there. You could have just done an inline structure. I mean, maybe you'd kind of want to say you could pass around the arguments to that. Or maybe it's like lambda.http just to collect all that stuff, but it still uses the same ports under the hood. Rather than being a fully separate thing in the same way Elm is. And that would certainly be one level of the baby step there. Then you decided to want to separate port it later. Of course, then like your management layer has to handle that somewhere. And like you do double nested programs or oh, then you have to have something like the command map to lift things up. So now, this could move below the line. HTTP request here is wrapping that in an effect, which maybe we do function wrappers for that? So I can actually remember HTTP requests and 2 Lambda requests that are dealing with that. And then this is the little helper we use for generating effects. Which has to have that correctly formatted type. So technically, you would be there. Because if this is at application level, that is a specific thing. Likewise, well, no, HTTP effect, that's in the definition of effect, which when we were playing around, we found that we could not say, well, an effect always has an HTTP message. We need to be able to talk about that at the independent of the application. So do I? No, you are still in terms of effect, but we still put the perform outside. And we're not properly using an effect here if there was a startup effect. So we would need to do something we would have to perform that with our initial model. Oh, and I was thinking about wrapping up perform too. All right, so far, we've kind of moved that down. We're going to have a whole lot of renaming. So how much trouble is it? Some of the coding stuff. That relates directly to the events. Okay, so you are not going to not need Lambda prefixes. Lambda message will be sort of fine. Lambda model will be okay. We could possibly get rid of it. You are now using a dict. And we've had too many events. Update event, use that again. Ooh. Uh-huh. And this is what you learn when you change scope. Well, this might have just been kind of a pre-mapping stage here to try and save us some trouble. That is indeed a Lambda HTTP error to my local HTTP error. The point of my HTTP error was to include bad body, which is not in this file. So now we have two levels of HTTP request and 2 levels of HTTP error. So HTTP error, lambda.http error, well, that would happen internally. So this one wouldn't even appear in this file. And these are all R's, which would become lambda HTTP error. So what do we call these? Like, HTTP port errors? And then that would not get exposed. So it's like, having done this, we can see all the little things you would have had to do as more baby steps, but it's really hard to see them without actually having things in a required namespace. So decode response. So response, you don't, well, decode tagger might put a constraint on it. Which HTTP error was this, though? Well, this is all the expect stuff that we just imported, so that's that HTTP error. So this should all be the inner one. That's going to end up being the public one. And then we get down below that stuff. Is it a port error? Is it a backend error? Are these network errors? We've already got a network error. Versus bad body errors. These request errors. Well, I need something for it. Okay, and you're not directly referencing any of the other stuff. So this is going to be really super confused for a while. All right, so bare HTTP error. You're going to become a Lambda. You know, I didn't expose anything else. How much do I reference this, though? It's the error mapping. Not that much. All right, wait, an HTTP port error. That had not gotten copied yet. Oh. I used to have namespaces for that. I'll let you kind of cheat on using the same symbols. So it's like we've done a bunch of stuff. And it's hard to see some of the changes because it all got moved. I almost feel like for this kind of refactoring, you could actually, this is the kind of refactoring where more modulars are useful in separating your namespaces. Right, so that is for some of the encoding and decoding. Right, so that's for the Lambda message style of things. Reply is for what's going over the wire. So unfortunately, it's not turning out to be a thin layer. So a lot of this, well, you were a port module. But that's only to have ports directly in you. Well, I really need to move these over piece by piece so we don't get things confused. Lambda source, Lambda. I think we might want to have like port level stuff. So it would have like port level HTTP error, like most of the stuff that's currently in the Lambda module we kind of go off of there. We pull out and re-expose some things. So session name be part of the public interface. So it's like that's all encoding. And I specifically need to get like this type that's talking about just the over the port stuff. But there's like port, encoding, decoding, and that's kind of all it's done. But now we're kind of adding this extra library layer to it. And as part of that, we need a way to sort of contain, well, I guess you could do http.lambda.http.error versus the main module HTTP error. But HTTP is going to have to mention some of this stuff. Well, header would move over. Well, would it though? Type header, well, then HTTP depends on port, and port would depend on HTTP. We should own that. Well, port needs to have an interface for doing that. Although maybe this one is at the level of tuples. And then elsewhere we talk about headers. Yeah, let's just encode headers call. Does the HTTP module depend on this? It's going to be mapping its errors. Because if Lambda is still going to be the main surface interface, it's still going to have to talk about sessions, it's going to have to talk about events. It's like, I'm going to run into circular dependencies if it's the main face, but it's also providing like some of these definitions and things to stuff. Maybe ports is the wrong thing to move. If we did have a Lambda HTTP, it would probably end up calling into Lambda. Well, no, HTTP request would be made by the program. Although I guess things like decrypt are still called by the underlying system. Gee, how does that work? Oh no, that is an effect. So once we get up there, you won't be exposed. Event is the subscription. HTTP request will be in effect. Response is in effect. Oop. Who defines a session? That's kind of something that we talk about. If Lambda is our public interface, it's going to have to depend on port. If port needs to talk about it, it's going to have to define it. Port is going to decode events, so it's going to have to define events. HTTP errors, this is going to be our port HTTP errors. It's going to be the decoder event source, encryptor. Leave the headers here for now. So the awkward thing for you is that we're just going to have to do a whole bunch of type things. Ooh. Can I re-expose everything if it's HTTP error? We shouldn't have to expose at that level. Event, well, I don't know if I can do that yet. It's like we want to cut some of these things off, but we had not actually done some of the other code moving here necessary. And all of that stuff is still getting called directly. This is the only way to like re-expose things. Or I go in and change all the references to port and then try to work those out of the program. which I guess sort of makes it maybe a little easier to hide them. Now, these are not going to all be type aliases. Like, these are just going to be event, decrypt. I'm pretty sure that if you just do an expose all, that doesn't really solve the namespacing problem. All right, step one, get this to work. Move their header. And that currently takes over everything. Suppose it cannot be used with a type alias. So I would have to explicitly expose every constructor. Well, if I expose it, and I'm pretty sure that it tells us we can't re-expose things. Yeah, it has to be a proper local definition. So I'd have to explicitly expose every single constructor. Well, I mean, the events will eventually be internal. The HTTP errors will eventually be eternal or internal. Probably the answer for this is that we do go over to handler and say import lambda.port as, well, that might be some name collisions. Lambda.header is ambiguous. So if we did that, it's not expose an event type. And then somewhere we're going to switch off of the values of those. That might be it. And somewhere we're going to have to deal with our HTTP errors. Okay, not HTTP error. Okay, it's compilable. And these are all things that we need to work out over time. Now, indeed, for everything that we don't necessarily need to re-expose, which is just about everything, We could just import port and then work out port. Well, there'd be one or two things like Lambda HTTP request or something. Lambda.session. We actually would still need to talk about Lambda.session, Lambda.session. The headers would want to move to HTTP. And then this is all below the line. Although you kind of need to get rewritten in terms of port as well for the internal stuff. Right, and this took over some of the things like making calls into HTTP and things. So this stuff is mostly not used from Lambda anymore. We'll eventually want to event? Do we expose event? I'm not sure we do. Now we were still using that by way of Lambda reference for all this stuff. But the internal definition is going to start changing to, well, it's actually changed to the local definition, I guess. To port. It'd probably just be session, but. HTTP request. Oops. Okay, so that's compilable. So that's actually just that is sufficient to separate HTTP errors. Because you got port HTTP error, and then the one we would talk about as like the Lambda HTTP error. The HTTP section might still kind of be able to use its own little thing. But I think we need to move this in smaller pieces, although you're going to get entrailed moves, which make it a little trickier. We're going to have HTTP request, expect. There's probably some use in having a Lambda source. Oh, that's right. I actually can't complete some of the edit. Once you get like a space, it's like a space or something that throws it off. And this is awkward because we're not actually exposing anything up front. But HTTP error, we would have to move the type first. And then we've got something to expose. So it's just an error now, effectively. And then you so now HTTP error. It's a message. That is still a port HTTP error. Decode.error. Aha. Bad status. And then all of these are no longer locally available definitions. They might become them again. It's not exposed, right. Got to expose all the constructors if we want to switch off of it. Cannot find HTTP error in handler. Oh, I replaced a... That's probably when I wasn't supposed to change. This is probably supposed to be this thing. Okay. Then we can take this mapping function. You're defining the HTTP error, so you would have this. To our local error type. Oh, we wouldn't call this public error. Okay, so this is not going to be long-term exposed. And we're trying to keep from this giant modeled ball of errors that you get from moving the whole thing over at once. But that itself, let's update events. So that's still going to have to be referencing something. That's going to be like the program level. And maybe you just leave that in its regular old Lambda. What else do we have? Port.http response. Yeah, that's fine. We had an HTTP request. Oh, we had expect. That's the system. HTTP model, I don't want to get to that yet. Decode response is actually part of the expect system. Can we move the whole thing over? HTTP match isn't too far into it. So if we just get decode is pretty much implementing expect. Okay, so that's going to be a local error. It's a variable type. Expect. Do we need to be able to inspect this? No. So we could make that private in a similar way that regular HTTP message does, or HTTP module does. Expect string, bad body. Oh, wait. I know that's the embedded thing. All right, and then what? Expect JSON we definitely need. At the moment we need decode response. That might be sort of a semi-private thing. Actually, is there any equivalent to that function in Elmland? Doesn't seem like it. But we would be calling that currently from our main loop, unless we have like a separate shell program for HTTP stuff. All right, so decode response, HTTP, expect JSON. And do we deal with expects anywhere? You do. And you do. And you do. HTTP match is probably going to move over here too. Cannot find HTTP. Is that you? Yes. Okay. So the HTTP model stuff is perform. Technically, the main reason for that is to do the remember in the response. Or the response to HTTP request. No, that's implementing effect. That might be more of a Lambda conceptually. Although this signature works because we're not directly referencing the inner model. But it's mainly for these, I think. Oh, but that would also save us. Does Lambda model is also parameterized in both. So not having to reference over there. Okay, so you're not using that. Let's do this real quick to make sure it type checks. That could have placed some additional constraints on things. I guess it compiled. And then this stuff is like kind of internals again. And if we were being really strict, we'd do like a lambda.http.internals that you weren't supposed to use from elsewhere. So HTTP model is only used, is not needed to be directly referenced. It's sort of implied in the signatures to these things. And we could possibly do something different with the names now. Okay, so now you need the dict. And do you need dict? Because Lambda model still is actually implementing that. Parentheses. And then we need to lose some HTTPs because it's in its own module now. Request ID. Well, that actually, that actually does kind of come back to this being this module, huh? Which that didn't get moved over. It has to do with HTTP requests specifically. That not updated. Did I put the model down here? I did. It's kind of specially related to this, or to HTTP model stuff. Now this, to make a thing like this, you have to expose that. Which for now is going to be that. And that is to Lambda request. Is it a HTTP request specifically? So that may be a good candidate for the next step. Next request ID. Oh, we didn't save you. It's 2 files now. Cannot find HTTP request from Lambda HTTP. So I missed that was a dependency here. And then this is sort of the public request, which Well, there was expect. Expect. I guess you're even just request at this point. HTTP, oh, stops doing this process. Oh, no, because we just got one more. Cannot find, oh, I didn't trace this good enough. Because you actually use that. And you're probably the only thing that uses that. And we type check again. So that doesn't need to be exposed or used here. You're doing all the request ID management. So if we wanted to go hardcore on that type at some point, we could. All right, what do we got left? We've got update event. We've got initial Lambda model. Lambda init, Lambda program, Lambda message, perform and effects. So that's probably already a pretty huge step. I didn't even really checkpoint after pulling the port stuff aside. And when we're all done, we're going to have to examine, like, do we re-expose HTTP stuff just from Lambda? Do we keep doing lambda.http? There's probably a better name for like lambda.port too, but perhaps in time. All right, so lambda model effect would definitely have to be a public thing. Perform depends on both of those, so they would have to get moved over first. depends on the Lambda model type and the Lambda message type. So then maybe this is what, and I could look at lambda.program thing. All right, so this is another one of those things where we definitely have to expose it as we move things over, and maybe we revisit that later. But this is an opportunity for some renaming. I probably didn't hit save over here yet. Dict again. http.expect. I may have been able to declare this as HTTP model of the like app as a model type. I don't really know if I could do initial model with that kind of juggling though. So this would be a good place for you, which for the time being has to be exposed. But you can go down to here again. Oh, but you're not a lambda.model anymore. Okay, so that types checks. Lambda.model. So I've got lambda.program. Perform. Lambda is going to implement the effects, but we're currently. I'm going to have to think about how we expose effects, but they're going to move up there. You mention effects. You mention effects. You mention effects. Technically, subscriptions could move. Although really that's just going to follow. It's going to follow the app. So I think we kind of have to move effects. And then, unfortunately, I might alias effect in here. We'll see. Of course, there's still all these sub-names, so to speak. And how much? So we've got app init. No effect. Step, pen state. Well, I guess command is something that gets exposed at the top level. And this is kind of a command. And then maybe we kind of revisit some of that later. Effect, HTTP dot. You to redefine session. Oh, you do have to know about secrets, which are not directly part of Lambda? So you're in kind of a weird space. Cannot find a value type. And where do I have that? That's a response session. So that's specific to what we get back from HTTP request. So maybe there's something that could be done there. So that gets us the effect type. So we've got lambda.model. Effect is not currently typed because we're just going to be leaving that there. That is well, this perform is specifically implementing effects. Do we have anything about Lambda messages? Not per se. Perform is called by Lambda program. So I guess we have to have that first. Port HTTP. Yeah, that was perform. Not exposed. I don't know if it should be long term, but for that baby step it has to be. All right, so Lambda program needs a Lambda message. Lambda init. Is going to be part of Lambda program. And actually, this starts just becoming it. Oh, except I used the name init here after all, including in the structure. So we're kind of stuck with naming that something. It'd be nice if it was lambda.init, but we've also got a structure that's init. Okay, so this as an argument is fine. When we get to the record stuff, stop it. Yeah, then I won't be able to use this format. We're going to have to actually go some kind of like config, and do like config.init. All right, you need to be able to call update event. Update event does, let's see, Lambda event is just a type alias, so it's not even like super critical. For its session. Wait, where do you decrypted? So, you know, got more secret specific stuff. Maybe secret should be part of Lambda, although it's kind of a general thing. Support, secret effect, Lambda message, Lambda model. I guess Lambda message could become some kind of message here. You have to be exposed for now. Actually, this starts just becoming your update function. But then we're back to this. We have to reconfigure how that, or reconsider how that gets configured. Update event, update event. Ah. And we didn't move over Lambda message, which we actually sort of don't need until we get down around here. And, well, we need this, but that can kind of go wholesale. And maybe since we're doing all of this, well, I guess in a standard Elm setup, the program is up top and all the definitions are down below, which actually it kind of was. We just had to pull out the prerequisites first. Well, perform kind of goes with effect. Oh, but not, it's now not a Lambda program. It is a program. type checks. And we would there be any reason to expose the init and update then? I mean, conceptually, no. Maybe you wanted to do some kind of like testing or something? Model's going to be a Lambda model now. You don't need dicks. Probably still need values. Yeah, that's your message type. Maybe we don't need as much. Okay, we're still doing some decode stuff. I don't know that we're doing any generic encode stuff. Platform is... I guess you don't need to import that one. It's already available. So there's still some cleanup that could possibly be done here. But we've got, well, we pulled HTTP out, which is another almost 100 lines. Also, okay, so you're not called directly by this module. That could use a better name. Expect is fully public. Code response is kind of internal. Request is primary interface. Code response. So there's http.html match, http.code response, http.public error. HTTP match ID. It has to be modified or already modified model. App update. So the code response is taking the expect and turning it into something. We are result mapping the error. With that function. So I feel like there's probably room to bundle some of this up into like the message we need to send, because that's kind of what this is. So it would be a message in a model instead of an expect in a model. And all of these things produce messages. So you might have a thing that's like, apply message to submodel. And that's in here. Anyway, that was a big step. That was nice clean deletion. And mostly just moved over there with some renamings. So instead of HTTP match and HTTP decode response, we might still want those internally. But what this thing wants is, remember, HTTP request, HTTP match, decode response is technically executing expects. Kind of. Well, switching the expect, and is that an expect.map? Not really, because a map would take a function. The function here is actually in the expect. This is more like a... Why are we calling this the code? Maybe that evolved from something else. So this is like applying an expectation. Which, of course, if it's an expectation method, then you would actually think of it in terms of reversing the arguments. Because you typically do things last. Well, you produce an expect, then we would do something to it and then send the message. But we've also got to get a model out because we're changing our state. So should this thing execute the expect? Well, to execute the expect, it would have to receive the response of the result. So this is mapping the other kind of errors, and then expect JSON. Any of these things that fail to decode can then turn that into a bad body error if it was successful to begin with. Apply U to the response. So we write a mapper. a function that takes a result. And this, yeah, and a result and then. So if it was successful in HTTP terms, we apply the decoder to it, which is, okay, this is applying a decoder, which is what the expect is doing. From function names and things, maybe apply expectation make more sense. Anyway, we want to, given a result, map its error pull out the appropriate mapping function which is going to be a state update. So that is going to be a response to message, or result to message. And I guess the response includes the ID. So that kind of wraps up both this stuff and that stuff. So the signature we want is like HTTP 2 message. Which is going to take a request ID and I guess you deal with the incoming result type, which I didn't actually copy because we were scrolling around here. And we want to, this is going to be a model update. So ID model. So typically model would be last. A model here is going to be an HTTP model. And remember, it has to deal with actual actual messages. So this separates, no, model last. Not just you, because we have to return our model again. Oh, that's our HTTP model. Do we have a... Got a little bit of this going on. Like, I'm not sure any way we can really avoid this except having some kind of other wrapper for it. Decode response, we're not applying a model. Once we get to this, we could view it as, well, message equals result. And this is where we get to remove a lot of HTTPs. And we still have to do this stuff because we've got probably... wait, you're in effect? No, that's a message. The effect is the result of the app update. And app effects is this. And that's returning two things again. So this is probably still gonna have all that to do with that model update. All right, so you should not need to do that. Technically that. Argument is result error string expects port.http error. Oh, I probably have to change that type. HTTP model app message. Two messages saying it should be model. Oh. Indeed. I haven't actually run this in a while, but we've really just been moving things between files. And what do we got going on here? Well, I keep calling this apply app update, but actually, could that be the function I passed down here? Like do some pre-computation. Let's do it directly first. It might save us an argument somewhere, but so that is the update function. Which I guess that we can kind of a configuration thing. And then you're going to pass that a message. And a model. Oh, what kind of model? No, we want to do a Lambda model. App update message. App update. This will all be condensed from above. Model.app. Oh, this went a little weird. So that's just really just applying to the inner model, keeping the effect. And actually, for a lot of this, we could probably have an equivalent of HTTP model that was like app model. You'd still do like initial model or something that would have more concrete idea of what's going on. So then you would be app update, new message, accept 2 arguments. Oh, we didn't do a return type. The return type for you should be the same as the return type for this. So you are encrypted result. Oop. And this might come back to streamlining the whole subscription style thing. Now this Still has to have the let. I mean, it's a little bit cleaner. Now, does this signature message model our model with the effect of applying that message so that would change you. Well, apply update is still there. It's message. Well, we're still getting a function, and it's actually a slightly longer signature. Because it's my wrapper model. Maybe we don't do that. Maybe that's something we have to think about in terms of the other. What we do with subscriptions. So it's kind of lifted. HTTP effect name. Okay. Encapsulate HTTP responses. I'm not sure what that means. I might have kind of done that already. App update helper. So my effect, which would be a Lambda thing, right? Yeah, so we got this HTTP. Okay, so this thing locally has no thing that's called HTTP request that would give us duplicate constructors. And it's HTTP dot request where it is. That's an effect, and you are the interpreter of effects. But who is the generator of effects? Well, we're still exposing the type into here. Now I've got this as a thing. Okay. What did that mean? I mean, that might be the toMessage function we did. So this is a little bit nicer. So that might have been what I was thinking of. Where do we make an expectation? We just save an expect string. An expect is that. When we come to decode string, we are pulling that thing out and applying it. I guess we could make an expectation into a function. It's got a function in it, so it's not necessarily making our data model that much worse. Then it would just be we apply a result to the expectation, and well, does a message pop out? 'Cause that's the code to message. Yeah, that would be performing the whole chain of response stuff. Okay, no, that can't be completely contained. You still have to do the HTTP match part, which is pulling stuff out of state. So if it was a function, it would have to be a function of the model. Well, we've already got that type, but we kind of need all those parameters in the function you applied. So pull it out. So if that was wrapped up more, it could perchance do the result mapping. Maybe the decode response should do that, because that's a result of HTTP error. So that would be already, yeah, that would be undecoded error essentially. So that's response. Although if we did that, we'd have to do like a let error mapped response in. Should be kind of annoying. That's mapping the decode error. This is a result and then. So I guess all of our expects could do result map error, public error, and then. But we're doing it once right now. The tagger is result HTTP error. And just gives us the expectation. Just the result HTTP error. Okay, yeah, that's port HTTP error. That would change the expect JSON type. No, because that's the tagger. which gets applied downstream. Hmm. Yeah, that could maybe go either way. I don't have anything concrete on this right now. I mean, it's sort of encapsulated by the program. So we've got next action, we've got kind of a general. Can we clean up our handler to make it look more like our idealized version of how much this would have to be doing? And maybe I can do that, because this is just HTTP, but maybe we can look at what request we're making and have a different thing here, which just shuffles some stuff around, but it makes it less state dependent. Well, it's lunchtime. Thanks for watching. Thanks to subscribers who support me, and to all the people who hosted me. What do we got? There's some view and node. That's pretty similar. Or ish, anyway. So if you're looking for someplace cool to hang out, Shin Best is doing some view and node stuff. Thanks for hanging out with me. Goodbye until next time.